This is Unit 2, Lesson 3. In this lesson we will talk about separating mixtures. Now before we talk about this, it's important to understand that pure substances, remember pure substances are elements and compounds, cannot be separated into simple components. They're already simple components, they're already pure. They cannot be separated further by physical means. But mixtures, because mixtures contain different substances, they're kind of mixed together, you can technically unmix them and separate them using these techniques that we'll talk about. Now here it says that pure substances, compounds, can be broken down chemically, but this is only true of compounds. So compounds can be broken down chemically, elements cannot. Elements already are completely broken down, and that's the idea. So elements already broken down, they cannot be broken down physically. But here we're going to talk about physical changes. Essentially all these techniques, there'll be 5 of them that we'll discuss, are all going to be physically changing. So they are all physical changes. The first one is filtration. This is probably the most common one. Most people have heard of it, and we use filters all the time in brewing coffee, for example. What you do in filtration is, here you have a funnel that's set up with a piece of filter paper inside of it. Usually it's a circular piece of filter paper, then that's folded up and placed inside the funnel. And what you have is you have a mixture of a bunch of liquid and a bunch of solid components. And you want to separate the solid from the liquid. You pour that in here, and the solid collects inside the filter paper, whereas the liquid actually drips down and collects inside your flask. So that's the idea of filtration, separating a solid liquid mixture into the solid and the liquid. Really simple. So when you're brewing coffee, the liquid of the coffee that dissolves the coffee goes down, and then the solid components remain in the filter paper. Method 2 is called crystallization. Now crystallization allows you to also separate a solid from a liquid, but in a different way. The word crystallization means forming a crystal, and what you have is you have a solution. So you have a solution, and in the solution the solid is completely dissolved, so you can't really see any solid in there because the solid, like sugar, is completely dissolved. But if you let the sugar slowly evaporate, or rather let the water slowly evaporate, the water will evaporate, leave, and then the solid will actually settle down to the bottom. And slowly this will happen, and you can actually grow big crystals of sugar down here at the bottom. And this allows you to purify the solid. So an example of this is making rock candy. You may have heard of rock candy. And the way it's made is exactly this way. You dissolve a bunch of sugar in water, and then you let the sugar evaporate slowly, and as it evaporates, as the water level goes down, your sugar crystals, your rock candy, forms. If you add some food coloring to your rock candy, you can actually make them different colors. This is used to purify a solid. Purify a solid. You can sometimes help it out by heating the solution, and this will happen faster. So if you heat this solution, the water will evaporate much faster, come out of solution, and you'll get your solid much quicker. The third one is distillation. Now this distillation is separating 2 liquids. And here it says you would add heat, and the component with the lowest boiling point turns into a gas and leaves the liquid mixture. So if you have a mixture in a flask, say, of 2 liquids. Now the 2 liquids are completely mixed. So what you have is you have, say, this red liquid, and you have another blue liquid that's completely mixed with it. It's not that they don't layer based on density, they actually completely mix together. But because every substance has a different boiling point, we can actually use the difference in boiling points to separate the 2. So you simply heat the mixture up, like is happening right here, and the substance with the smallest boiling point begins to boil. As it boils, it actually comes up the flask. What this is a thermometer, and the thermometer registers the temperature at which it boils, so that way you can check to make sure you're boiling off just that first substance. And by checking the thermometer, you know which substance you're boiling off. As the mixture goes up, or as the boiling vapor goes up, it eventually comes down this tube, and then this tube has hoses going through it. These hoses actually just have water running through them, usually cold water. And the cold water cools this gas into a liquid again, and the liquid starts going down here, and eventually it drips and collects in this flask. So what happens is once you boil off the first liquid, the temperature jumps up, and then you can monitor the boiling of the second liquid, and you would have to change out this flask, and then you can separate, say if you have 3 different liquids in here, you can separate them by this distillation method. There's something called distilled water that you can buy at the store. We have a lot of it in the chem storeroom, and the distilled water is actually made this way. They distill it. They take water that has a bunch of other things dissolved in it, and they boil it off, collect the water, and this is called distilled water. The fourth separation technique is something called centrifugation. In this technique, you have to have a special machine called a centrifuge. So just like the name, centrifuge. What you do is this centrifuge has, you technically put little test tubes, so you lower test tubes inside of here, and the machine spins them really quickly. As the machine spins them, the layers, the substances in the test tube actually begin to layer out. So if you had, say, a mixture of a bunch of different solids and liquids, eventually after so beforehand, the solids and liquids were kind of mixed together, and you can't really separate them. You know that they're all there because you can see them all there, but you can't really separate them just by letting them sit there. But this machine will actually, after you put it into this machine, you'll actually get a test tube out with them layered out. So say, for example, the green substance will be layered at the bottom, the red substance will be in the middle, and the black substance will be at the top. Now they'll actually layer based on density. So these will layer based on density. And usually to do this, they have to be solid components. So these are actually solid components that are just mixed together. Solid, or sometimes they can be semi-solid components. And a centrifuge will actually separate them out. So that's how centrifugation works. And the last one, the least known about, is something called chromatography. This is the most maybe confusing one and hardest to understand. But what you do is think of pen ink. So a black ink is usually composed of many different substances. It's a mixture to make it look black. And what you do is you put the black ink at the bottom of a little strip, and then you lower the strip into a beaker. You'd actually set up a beaker, and with a little bit of a special type of solution, and that solution usually can dissolve that black ink. And as you put the strip down in here with the piece of black ink, slowly the solution will actually dissolve away the ink and separate the ink into its components. And what you see here is you see that that black ink is actually made of a bunch of different colors. In fact, you have most of the colors of the rainbow there, and you don't get a lot of a substance out of this, but you are able to see that the substance, how the substance separates. And based on what type of ink your pen is made of, it'll actually make a different color streak. So you can actually determine the type of substance you have by doing this little chromatography experiment. And we'll show you an example of this in the lab, but here it says that the smaller components will actually be absorbed quicker and will start to move away from the larger particles, but it also has a lot to do with solubility. The substances that are more soluble in here in the ink will actually move farther up. And so there's a few things going on. Solubility usually is what makes this happen. The substances that are less soluble will actually deposit down at the bottom. If it matches the solubility of the paper more, it'll deposit at the bottom. If it matches the solubility of the liquid more, it'll be taken up higher on this strip. Alright, so hopefully that makes sense. And why don't we do an example problem, and then we'll let you do a practice problem. Here it says decide which mixture separation technique should be used to separate the following mixtures. So we have a technique that we want to use to separate salt from seawater. So salt can actually be obtained from seawater because seawater is very salty. And if you take a bunch of seawater, which has a bunch of salt dissolved in it, usually there's more than one type of salt in the seawater. If you let it just sit there over time, as the water goes down, the salt will be more and more and more concentrated. Eventually, as the water goes down, you will actually see salt crystals form. You'll see nice big salt crystals. And eventually, hopefully, you just have a bunch of crystals at the bottom. So here's a big salt crystal that you'll end up with. So this then is crystallization. Again, you can help the process out by adding a little heat to it, and that heat will drive the liquid water off and create yourself some crystals. So salt can be obtained from seawater by this method of crystallization. The second technique here is we need to use something to obtain drinking water from pond water. Now, in this case, some people may say filtration. You cannot use filtration because what you'll get at the bottom of the filter is still water that's not suitable to drink. It's going to be pretty dirty still. So what you want is you want distillation. And that's why distilled water is called distilled water. What you do is you take your pond water, and what you'll have to do, again, is probably use a special apparatus, the distillation apparatus. But if you heat the water up, what you're doing in this case is you're actually capturing these water vapor fumes and putting it in a special container or a separate container, and that will make pure water. So this will be pure, whereas down here at the bottom you'll still get dirty pond water left behind. So you want to use distillation for this separation method. And then go ahead and try 3 of these, and hopefully that will wrap up for us all the 5 types of separation techniques. Alright, so this wraps up the video.